We are starting the advanced storage for infrastructures for demanding workloads webinar. This is a live session brought to you by DIAWAY and Western Digital. Thank you for joining us today. Please, all of the attendees, do let me know if you hear us in the chat, because we need to know if the connection is fine. Okay, thank you. So make sure that you are here with us for the next 30 minutes or so, because we have a lot of amazing prizes for you, and we will have a short quiz based upon this presentation in the webinar. So make sure you pay attention, and we have amazing prizes, really. So we have a fashionable black t-shirt from DIAWAY, wireless power bank with 10,000 ampere hours. That's, you can charge all of your devices almost. We also have a special prize from Western Digital, which is a 64 gigabyte SanDisk USB stick, pretty cool one, and small stick, and also the super prize for European Union attendees, a fine wine box from DIAWAY as well. So all of this is the prizes we will give out for the quiz participation, which will be in 30 minutes. So stay with us and make sure you pay attention to what's going on. So let me give you the agenda of this advanced storage webinar. Here is what we will cover in the webinar, and you will learn in this webinar. So basically, you will learn the top mistakes that are made when the software-defined storage is planned, and these mistakes make people lose a lot of money. You will get behind the scenes of the 220 petabyte super case study with a cronis designed by DIAWAY. You will also learn the advanced approach of measuring the costs of ownership for your software-defined storage. And you will get the technical overview from Western Digital and learn about the innovations from Western Digital. And of course, win the prizes. Yeah, I've mentioned this before. Okay, so let me present the speakers today. I'm Liliana. I'm moderating this advanced storage webinar for DIAWAY. We also have Dmitry Lyautov. He's the co-founder and managing partner at DIAWAY. Also today with us is Manfred Berger. He's our special guest from Western Digital, and he is also senior manager of business development for platforms in Europe, Middle East, Africa, and India. And for the Q&A session, we have Alexander Ragel, who is the co-founder and managing partner of DIAWAY. Allow me to tell you a few words about DIAWAY, about the Advanced Storage Webinar organizer. So DIAWAY is the big data storage and networking integrator. The company designs, deploys, and optimizes systems, software, and storage solutions that enable enterprises, cloud providers, and software companies to generate more value from their data. As you can see from the slide, DIAWAY has helped quite a few leaders of the industry to save millions of dollars on the right sizing of hardware for their data storage. Important topic. DIAWAY is also the official partner of well-known companies such as Western Digital, AMD, and other global hardware and software vendors. So, the introduction is fully made. Let's begin our advanced storage webinar. And now, Dmitry Lyautov, the co-founder and managing partner of DIAWAY, can you give us an idea why we even organized this advanced storage webinar? Why? Tell us.
Hello, everyone. So this slide is about my favorite topic, money. And the reason why DIAWAY created the advanced storage webinar is because the SDS market is booming and going to reach 86 billion by 2023. While there can be some fluctuation with pandemics and such, the trend is obvious, and SDS market will be huge. The data growth is exponential and like never before. And the huge growth potential means that even small savings through optimization will yield much bigger savings with the data growth in future. And the main question is how. And this is what I am going to delve into a bit. So, working with multiple companies across the globe, we learned that many of them making the same mistakes in planning and building their software-defined storage infrastructures to lose them $1 million. There's no single commonality that we can pick up. We can outline a few examples. For the next two operations, let's imagine that we have already the best possible infrastructure design that saves our money on entire life cycle, and the only way to optimize total cost ownership is to drop down the hardware cost.
Okay, Dima, quick question. So there is this myth that if we need to save money, we need to go to the bigger supplier. You know what I mean? So we can get a bigger discount, a huge discount from the larger, more powerful supplier. Is it true that it's possible to save money on this?
Well, it could be a general rule if there were not so many exceptions. Let me provide an example of such an exception. So one of our customers used to buy servers from one well-known American manufacturer directly. However, it turned out that our terms were much better for exactly the same hardware, and they switched to us. And obviously, DIAWAY as a company is at least 1,000 times as less compared to this manufacturer. Yet it turns out that our offers are better to the end customer. And of course, there's no magic. And the plain truth boils down to manufacturers' pricing tier they're getting, lower flexibility on components, cost optimization, and probably inflated expectation on margin levels.
Okay. So now we see that the strategy of choosing the bigger supplier is kind of not the best way to do it and not quite right. And we had a poll, and we had a few people answering that it's a good idea, and most people said that it's a bad idea. Yes, it's a bad idea. So, okay, another conception, and listen carefully, everyone. So the other conception, if we need to save money, is maybe we should make a tender, the competition. And maybe it's beneficial to the client when there is a fight, between different suppliers. They, want to win. They make the better price, kind of. So listen carefully. And Dima, is it true that competition is the key and good strategy?
Well, we call such an approach an opportunistic procurement approach. And here is the spoiler. It doesn't work as it's expected. And the reality might seem illogical at first. So let's discuss the pricing. I believe there's no doubt that fair pricing depends on the annual volume tier. And that's why I guess no one argues the fact the bigger the annual volume, the greater the discount. And now let's imagine that our customer uses opportunistic procurement on every single order. And then none among the suppliers can use the entire annual forecasted volume to deliver the best price for the customer. And this is because the volume is always split across the multiple suppliers. And when both supplier and customer consider the infrastructure growth as a project then the fair pricing will be defined based on the forecasted volume. So the reality is that trusted partnership is what really secures the best pricing, not standard procedures on every incremental infrastructure growth stage.
Well, can you imagine 22% of the attendees of the Advanced Storage webinar thought that competition is a good thing? Guys, sorry, no. Partnership and better pricing gets from the most trusted partnerships. That sounds like DIAWAY a lot. This is what DIAWAY does, actually. I see your point, Dima. Thank you for the explanation. And last but not least, the third point we need to discuss today on this webinar is like when you get the cheapest hardware, the total cost of ownership is also less. So you buy cheaper hardware, you get lower costs of ownership. And if we are focused on the cheaper the hardware for software-defined storage, we kind of believe that the overall pricing will be lower as well, like cheaper hardware, cheaper prices. So make every piece cheaper, make cheaper the whole. Is it true, Dima?
We had a similar case just recently. A good example of this myth from our latest case study with Western Digital and Cronis. Cronis is a leading cloud backup provider. They needed to build a global 14 data center infrastructure to store hundreds petabytes of data. When Cronis approached this project, they were thinking that they need cheaper hardware to have cheaper overall price of storage. And this is exactly the myth. Cronis was focusing on making the infrastructure block as cheaper as possible. And the project goal was to optimize the storage costs. Cronis hired DIAWAY, and we created sophisticated financial model that measures the total cost of ownership with one major metric. The major metric is usable terabyte cost. And surprise, it turns out that cheaper hardware has many hidden costs for maintenance, lower reliability, outages that leads to a much higher cost of ownership. Cronis' goal was to make the terabyte cost as low as possible. And DIAWAY dropped down the terabyte cost by 50% by using the right size hardware for Cronis needs. This is how this amazing case with Western Digital was born. You can go to DIAWAY website and download this case study to learn more and ask any questions during our Q&A session. Everything we discussed earlier, project approach to data storage sizing, we call it economics, techniques plus economics. And we always use this approach for infrastructure optimizations. And this approach is built around a few key elements. So the first element is consolidated TCO, total cost of ownership metric. For software-defined storages, the key metric is usable terabyte cost. The second key element is initial footprint and project RAM. And the third one is a right-sized building block. Let me cover these three elements in more details. So for TCO metric, it's quite important to consider all costs involved, including data center costs, and build the model based on useful capacity, not on the raw as many vendors do. And to know the forecast is a key here, because forecast determines the building block to select. And this choice will directly impact the total cost ownership over the life cycle term. And building block defines the whole economics. It is critically important to be hands-on with new technologies, as they will let you build right-sized building block better and with more efficiency. To cover more on this site, here is the word to Manfred.
Yes, we have today with us a special guest from Western Digital, Manfred Berger. He's a senior manager of business development for platforms in Europe, Middle East, Africa, and India. So Manfred, I am making you the presenter. You can now share your slides about the innovation going on in Western Digital.
Yeah, just switch into the presentation. Can you see the full screen presentation?
Yes.
Okay, thank you very much. And apologies for looking different compared to the image that was just on the screen. My barber shop has been closed for coronavirus for 3 weeks now. I promise I'll shave when this is over. So back to the topic. I work for Western Digital, which is a technology company that has acquired many other companies over the year. That's why we can rightfully say, as shown in this picture, we invented the hard disk drive in 1956. We invented the first disk drive array in 1976. And many more things on this page, which were either industry firsts or very relevant contributions to the technological progress of the industry, be it the perpendicular recording or the helium-filled drives in 2013, be it 3D NAND technology to make NAND reliable, of very high density and enduring, or the energy-assisted recording technology, MAMR or microwave-assisted magnetic recording in 2017. All this results in 5,188 active patents for Western Digital, but the total actually is 13,300 patents that have been issued. Many of them are still in review, but nonetheless, we're in the top 4 worldwide. This is the total storage portfolio. Most people, when they hear Western Digital, they think of our client drives, the blue, black, red, purple, gold, and others. But actually, we do everything from NAND chips for phone manufacturers. We do home and small business NAS devices, as well as we have a whole enterprise class of products, which is what I'm circling down here, be it the drives, the SSDs, or the platforms. Personally, as was said, I'm in charge of platforms. We exclusively use our own enterprise class HDDs, of which there's 2 families. On the left-hand side, you see the air-filled, cost-effective models from 4 to 10 terabytes, all 3.5-inch form factor, and either with a SAS or SATA interface. On the right-hand side, you see the helium-filled, more energy efficient, quieter, more reliable drives, ranging in capacities from 10 to 14 terabytes today. But we've already announced the 16 and 18 conventional recording hard disk drives based on helium technology, as well as an SMR drive, which you will hear more about. SMR stands for shingled magnetic recording, which is a technology to increase capacity for backup and archive-like applications. Switching back to helium, why is this so relevant? Helium is a very thin gas. It has the 7th density of air, so it produces less resistance and drag inside the hard disk drive, and as a result, it also reduces flutter of the media. What I'm showing on the right-hand side are 3 graphs. The top graph is one created from an air-filled drive, where the friction of the air causes all kinds of resonances across a number of inside components. And you see the curve is rather rough. That roughness means the head is in motion at certain frequencies away from track center where we want it to be. And the rougher the curve, the less precise the track following. This can be partially compensated, as is shown on the middle graph, by introducing a second stage actuator that has a higher frequency response. So some of the lower frequency noise is actually reduced. But if you go to the lowest graph, which represents a helium-filled drive, you see that the whole graph is much smoother, which means the head is flying with higher precision, and therefore we can lay down the data at higher density. This is what a magnetic head typically looks like. It's a 0.85 millimeter black slider about the size of a grain of salt. having about mechanical clearance of 1 nanometer across the disk it is flying over. And for a 3.5 inch, 7,200 RPM drive, the effective speed of this tiny thing is 107 kilometers an hour. To explain what a nanometer is, if your step size was 1 nanometer and you'd be walking for 200 hours, you would have crossed 1 millimeter. So the nanometer effectively is next to nothing. Putting that in perspective and comparing that with an airplane, which in this case is 57 meters long, the effective speed at scale becomes 7 million kilometers an hour, and the clearance is just about less than a human hair at 67 microns or 0.067 millimeters. Back to SMR. In SMR, we lay down the tracks sequentially, as most drives would do, but we keep overwriting the previously laid down track, so the resulting remaining track width is much narrower than the original write width of the head. So the concept is clear, as the video just showed, but the benefits are in 3 areas. First, if we are allowed to write wider, we put more energy into the disk, so we have a stronger magnetic field and therefore can write smaller bits in a linear fashion. The fact that we're writing linearly always and never random within the track means the head is flying in a stable position, so we can lay down smoother tracks. And since we're going track by track from the outside to the inside, there's less magnetic interference from subsequent writes, so the laid down data is not being disturbed and proves to be more rugged and needs to be rewritten less often. The effective density increase is in the order of 20% today, by the way. We're also leveraging our own NVMEs, of which there are 4 families. The SN200 is trimmed for high speed, which comes at a certain price, but sometimes that needs to be paid if the need is for speed. But we've also introduced a more cost-effective family, which we call the Essential NVMe, which is effectively the future SATA replacement. It comes at much higher speed and bandwidth than SATA, but is actually quite close in cost as long as you compare drives within the enterprise family. We still have SAS SSDs in the portfolio. SAS is the one that provides you with best scalability. And we have SATA. However, SATA is not that often used in storage applications any longer. It's mainly used as a boot media inside servers nowadays. The family that is in use at DIAWAY is the SN640 Essential NVMe, which comes in 3 form factors. The E1L, which is the largest one purely for enterprise installations, at up to 30 terabytes. Then the M.2, the size reduced version, at up to 8 terabytes. And the U.2, 2.5 inch version, which is the standard server form factor, which ships in capacities up to 7.68 terabytes. The endurance of this product is scalable. It can either be 0.8 drive writes per day for the full capacity. If you create more over provisioning to make the drive more robust, it ships at 2 drive writes per day. And then it has 6.4 terabytes usable capacity. But actually the user can scale over provisioning up and down to suit the needs. And the other parameter that the user has control over is the power consumption. You can limit that in line with your thermal cooling capabilities, and you would lose some write speed, but the read speed is literally unchanged by that. Okay, now to my personal topic. As I said, I'm in charge of platforms. When we say platforms, we mean direct attach JBOTs, just a bunch of disks. As you see in the top row, the Data 60 is the shortest 60 hard disk drive JBOT on the market that I'm aware of. As the name suggests, this holds 60 drives, but up to 24 of these can be switched to SSDs because we have enough bandwidth to do so. We have a total of 12 host ports on this JBOT, so you can either connect 12 servers individually, up to 6 servers with redundant data paths. The Data 102 is a related design. It's longer, however. It has 3 extra rows of drives, holding a total of 102 hard disk drives or 24 JBODs. And on the right-hand side in the top row, you see a JBOF, direct attached, just a bunch of flash, which is hosting 2.5-inch SAS or SATA SSDs. The host connection in all cases is a 12 gigabit SAS link, regardless of the storage technology on the inside. The center row shows our server family. On the left-hand side, we have a SAS SSD-based mobile server of up to 368 terabytes. This is often used to carry data from data center to data center. So if a cloud provider like a Cronis wins a big customer and they have to bring the data over in the least time possible, this is actually much faster than an online connection, because one car ride away, you might transport 368 terabytes in a matter of hours. If you tried this over the internet, you might figure it takes months, if not years, to transfer that amount of data. The right-hand side shows a hybrid server, which uses the Data 60 technology, but it is in an extended case with a dual Cascade Lake motherboard. And in addition to the 60 drive, it can host 8 SSDs. If that's not enough, some hard drives can be replaced by SSDs in this design as well. The bottom row shows a very new product family that is network attached flash storage, or NVMe over Fabric, you might have heard as well. I'm not covering it in detail today, just a few key parameters for this. Since the NVMe's are sitting directly on the network, you don't need a server to make them available as useful storage to other servers. And the other servers will see this with the same performance as if the SSDs were local, provided you're using network cards that support the remote DMA protocol. But more on that later in a separate webinar. Back to the platforms, we have 3 focus areas for our platforms. Number 1, we want performance to be stable, and regardless of what jobs individual drives do, they should not be able to disturb each other through vibration. So we figured a design how to separate the drives from each other mechanically, which is by cutting out the backplane connectors and having them sit in rubber grommets. So in this scenario, if one drive is recording a video and another one is doing a database seek job, they cannot influence each other, and the throughput of the writing drive is unharmed by the seek job of the noisy neighbor. The other key technology is referred to as Arctic flow. That's a special cooling concept, and you'll see more of that in a separate picture, where we've divided the JBOD into thermal zones. So rather than cooling front to back in one go, where the drives in the back will turn hotter than they need to be, because the air would gradually warm up as it travels through the JBOD. But by having 2 thermal zones, we can basically cut the thermal spread in half and end up with improved reliability, and at the same time with energy savings, because what you don't heat up, you don't have to cool later. And the third focus area is serviceability. So we wanted a toolless implementation, and again, I have more pictures on that, to keep service times low and to keep the operators in the cold aisle for most of the service jobs possible, rather than having them crawl into the hot aisle where all the cables and other stuff will be in the way. Here's what our Data 102 JBOD looks from top. You see this center channel where the arrow is pointing. This is how we're bringing cold air into the center of the JBOD to be able to cool the drives in the back. The hot air from the first half of the drives is funneled to the side and led then out to the back, so it does not influence the temperature of the drives sitting in the back. The I/O modules have their own cooling path, they have their own blower, so they're taken care of as well. Here's what our JBOD or server would look in a rack. Every rack in a data center has a front, which is the cold aisle or the hot aisle in the back. We can access the blower for the CPUs the chassis or even the I/O modules from the front. Same is true for the SSDs, the I/O modules, and of course the hard disk drives. When you're pulling the JBOD forward, the rack cover or the JBOD cover always stays inside the rack, and you don't need any tools to pull the JBOD forward, because it's unlatched by its own handle. So as soon as you pull the handles, it unlatches and comes forward. And the front indicator LED will tell you which JBOD might need service by changing color or changing pattern. If you pull the JBOD forward, you'll be able to see which hard drives are asking for service, because they have a tiny LED next to them as well. Switching to the back, you can change the blowers individually, so you don't have to change whole PSUs like you might have to do with other designs. The PSUs can be changed individually. One is capable to run the whole JBOD entirely. However, we still recommend to repair broken ones as soon as possible. And the other nice feature, all these SAS cables are attached to the chassis, not the I/O module, which means if the I/O module goes bad, you can pull that from the cold aisle, and you don't have to take off the cables and then wonder where they had been. The other design feature is the so-called cable management arm, which holds all the cables, including the power going to the JBOD or server, so you can pull it forward without the risk of pulling out any cables, which could lead to a catastrophic event or even data loss. Speaking of data loss, we looked at the quality of our JBOD in the field. We had an early design that came to market in 2015 that has over 4 years of field experience, which is represented by this orange curve here. And the percentages that you see year by year are the percentages of annual returns. Annual return does not mean that a hard drive was actually defective. It could mean that the RAID controller didn't like the drive because it responded slowly, which could be a result of vibration or could be a result of throughput throttling based on temperature. So while the numbers at 0.45, 0.98 and so on are not bad, we were still able to dramatically improve those by switching designs to the Data 60, Data 102, which is represented by the blue curve. So see that the annual returns for any kind of glitch the system experienced were reduced by 62%. And the number of 0.19 per year is actually less than we originally projected when we designed the drives. So that the drives are behaving better than planned for when they were designed, purely by these parameters I just showed you, by the improvement through ISO-Vibe, improvement by Arctic Cool, and the other nice side effect is that service can be quick and efficient by operating the thing from the cold aisle. I've done some math. You might have seen examples published on the internet where people show something like a 1.5% annual return rate, which is quite a good number. We have seen other companies showing even double-digit numbers, but let's stay reasonable. 1.5% annual return, regardless of whether the drive is defective or not. In the case of a cronis, where they run 220 petabytes, that means 18,900 drives are in service in RAID 5, which leads to 7.5% returns over 5 years at $150 per service run, including testing, RMA procedure, and so on. That could have cost them over $200,000. You plugging our numbers in that I just showed on the previous slide, we're merely talking $27,500 in service cost, or potential saving over their installation over the use of 5 years of $185,000. So very significant, and it doesn't cost anything other than changing brands. Switching back to the Data 102, which is the JBOD in use there. As I said, it's a 102 drive JBOD. It can incorporate up to 24 SSDs. Today, we're shipping it with 14 terabyte drive. The 16 and 18 are still in qualification, as is the SMR. The maximum SSD we can support today is 15.36 terabytes, and the thing has 12 mini SAS ports, so combined bandwidth of 57.6 gigabytes. The smallest shipping capacity part is 360. The biggest we can ship today is 1.4 petabytes. And with that, I'm handing back, and thanks for listening.
That was amazing, Manfred. Actually, everybody who is attending the advanced storage webinar, this is the embodiment of the advanced storage, as they say, because now you can see how much innovation goes to engineering to make sure your data is in good hands. And this is crucial in the long run, and truly impressive. Now you see how is it possible to cut down the cost by using the quality engineering hardware, right? So pretty amazing. Thank you very much. And we will have the quiz in the end, so I hope you paid attention to what Manfred said, because several questions are from Western Digital, and the prizes are truly amazing. So by the way, if you are curious to know what technology DIAWAY also uses for different storage and software vendors, you can ask questions during the Q&A and wait a few minutes. So Dima, can you tell us a little bit more about the different approaches DIAWAY uses?
Okay, sure. Am I sharing the screen now?
Yes. Okay,
sounds good. So as Manfred mentioned previously, that these 100 based GBots are using in Cronis case study project we discussed earlier, but we can also provide some practical examples of Techonomics approach. For example, we have Cronis cyber infrastructure smaller footprint sizer, and let me share the page. So we have a public page about Cronis cyber infrastructure, and there is a sizing tool that basically covers the most popular on-premise installations use cases and capacities. So we can choose, let's say, archive, cold storage, and let's say we need 500 TB. So it's not multi-petabyte deployment, but basically the approach, the Techonomics approach is the same. So we can see complete Techonomics breakdown. So we can see servers hardware pricing, we can see support option, we can see networking gear, we can see data center costs, and of course we can see the key metric for usable TB space. And it all changes automatically depending on the specific footprint on the specific use case. And of course, we can see the complete breakdown for the specification. You can see data scheme. We can
Dima,
see...
can you bring a screen a little bit larger so we can read what the page actually says?
Okay, yes. I will try.
Perfect.
Does it look better now?
Yeah, we see all the details. Yeah.
Okay, I will show you again the details. So you using this Cronis cyber infrastructure sizer, you can choose the right use case you want to use, and you choose the usable space you want to use. So, and the numbers, the Techonomics numbers, automatically calculated. So you can see how, for example, servers hardware affects overall pricing. You can see the usable terabyte cost, and you can see the complete specs breakdown. And that's not the only one example I'd like to share with you. So Cronis cyber infrastructure is universal kind of storage, and of course the universal storage can be good for every specific use case and workloads. And I'd like to share with you two sizers that are not published yet. One is for file system oriented software-defined storage. The another one is for object oriented software-defined storage. So the first one is, oh, it's already big, good. The first one is about LizardFS file storage solution, and you can find the specific use cases on this page, and there's a similar sizer as well, so you can choose the specific use case, and you can choose the usable space you need. Like, let's say it will be 700 terabytes, and you can see, you can select how many files you are going to use. Like, if there will be enough, like 600 million files, then you will just select the value, and you will get the complete economics as well. And basically, the metric, the key metric is the same, so it's still usable TB space. And of course, you can find the complete specs breakdown as well. So, and speaking about another solution that we can provide for OpenIO object storage, we have a similar sizer here, and for this specific SDS, SMR drives that going to release soon, 12 TB SMR drives will be supported, so the economics will be even more attractive than it is now. And again, you can find the same approach across this this sizer as well. So you can see the key metric, you can see the complete economics breakdown, and you can see the specification. And this sizer we already discussed are all about the software-defined storage, but the economics approach can be easily extended to other kind of workloads. So let me provide an example for hyperconverged infrastructure. So we have a ready-made solution for Virtuoso infrastructure platform, and I would like to show you how it works for hyperconverged infrastructure. So the key metric is the key metrics of this specific case are about usable resources of virtual machine. So typically, you know how many CPUs for your virtual machines do you need, how many RAM, and how many storage capacity. So you select the required values for your cluster, and then
okay, can you make it a little bit larger again, because it's important? Okay. Yeah, perfect.
So the earlier we choose the usable TB space, but for hyperconverged infrastructure, the key metrics are not the same. The key metrics are usable resources for virtual machines. So in this case, we select how many virtual CPUs we need, how many RAM we need to address for our virtual machines, and how many SSD space do we need. And basically the approach is the same. So we can see complete breakdown. We can see how the specific kind of costs affects the overall pricing, and we can see the metrics calculated here. So what will be the cost for 1 GB of RAM? What will be the cost for one virtual core? What will be the cost for SSD for 1 GB of SSD space? And you can find complete specs breakdown as well in the sizer. And speaking about the hardware and infrastructure side of this solution. We are using essential NVMe drives that Manfred addressed in his presentation. So it's critically important to be up to date with modern technologies to get the best possible economics. Feel free to send your questions regarding these ready-made sizers. During our Q&A session, we will address all the questions. Well, let me share the presentation again.
Yes, thank you, Dima. I hope everyone got a view, a helicopter view around the economics approach to the right sizing. And
yes. So we can send you the whole presentation and the links, because some of these sizes are not published yet, but they will be accessible for our audience of our webinar.
Yeah, so this is exclusive information.
Yes, right now, yes.
Right now, at the moment, it's exclusive. Thank you, Dima. And I think everybody learned something from the economics approach of DIAWAY, and you can be successful with planning your storage or hyper-converged infrastructures, and use this approach. And you can define your key metric by yourselves. You can ramp and optimize the infrastructure building block. You know everything from this advanced storage webinar. And you can use the tools from DIAWAY website as well for the total cost of ownership figuring out. Or there's another option, the promised land of working with an expert like Dima. As you see, he's deep hardcore experts in everything regarding the hardware and the financial side of things. So you can work with DIAWAY experts. They can do all the financial and technical planning for your specific use case, because DIAWAY has long-standing industry partnerships with many software vendors, strong experience in right-sizing the infrastructures for various software-defined storages, and accumulated deep expertise in this kind of work.
Thank you, Liliana. So, making economics with DIAWAY is not a rocket science. The working scheme is quite simple. Let's kick off the conversation and proceed with design requirements, building financial model, design completion and validation, tailored fit for your specific use case, all to get a better performance and pay less. That's the main idea. And following this link, you can see diaway.eu/schedule. You can schedule an appointment with our economics experts.
Yes, I would disagree that this is not a rocket science, but still, yes, I strongly advise to schedule a meeting, because talking to Dima and Alexander is always a great pleasure, and it's always better and wonderful to have the bigger picture, how to actually measure and plan data storage. Shortly, as Dima said, we will send you the link to the presentation after the webinar, so you can dig into all of the economics approaches and figure it out. And now it's, we have finished the main part of the presentation for the advanced storage webinar. Thank you. And now it's time to win prizes. So we promised quite a few prizes. You remember the fashionable t-shirts, the SanDisks, and wine boxes, and wireless power banks. So let's have a small quiz. We will see how you listen to the presentation. And you can reply to the chat and the question section. I can see your replies. Just choose the right answer. So let's see the first question of the quiz. So the first question is from Manfred's part of the presentation. Which HDD achieved the lowest failure rate? Air-filled or helium-filled? Helium-filled. So is it air-filled or the helium-filled HDDs that are more reliable? Okay, we see some answers rolling in.
Let me know when I should change the slide.
Yes, I want to see some answers. Come on, you listen to the presentation. I see a couple of answers right now. Okay. It's good to see that we have some people from Western Digital on this webinar. They're not using their special knowledge to to win the prizes. Good for you. Good ethics. Okay, let's go to the second question. How many years of warranty are for the Western Digital's UltraStar platforms? 1 year or 5 years? A or B? Remember, the right answers will get amazing prizes. So, like, think a little bit. How many years? With such amazing innovation and engineering.
The products that actually saves your money by lowering the failure rate.
Okay.
Saving budget on smart hands.
We have results, and dear attendees, thank you for paying so much attention to today's webinar. Almost all of the answers are correct. That's amazing. Okay, let's go to the third and final question. This one is tricky. From Dima. What is more important, how do you think, for software-defined storage costs? What K metrics? Lower usable terabyte costs or cheaper infrastructure block? What is more important for the costs? Okay. Very impressive. With this, I think the people who attended today know everything about software-defined storage now. All the answers are absolutely correct. Okay, thank you very much. We have finished the quiz. We will distribute the prizes after we finish the webinar. We will contact you and let you know how to get the prizes. So Dima, can you switch the next slide, please? Let's just make a small reality check. So yes, the helium-filled are the lowest annual failure rate HDDs. The warranty is of course 5 years because it's Western Digital. It's it's the longest possible years warranty. And of course, the lower usable terabyte cost is the key metrics. And I congratulate everyone who gave the right answers. Thank you for your quiz participation and being so paying so much attention to the webinar. Okay, so this is it. We are perfect in timing. All of you will get the recording of this webinar. You can also use these several minutes to ask questions. If you have any questions, just put them in the chat and I will read it to Manfred and Dima. They can answer. We have a few minutes to do that. somebody answered incorrectly to the last quiz question when the connection was low. That's okay, don't worry. You had a few previous right answers, so you are all set with the prizes. Don't worry. Okay, so
there
if
was
you have
some comments regarding the myths, I guess, because I can see the chat.
yes,
maybe we can address these comments and questions that were during the presentation.
Yeah, some people thought actually that it's good to have competition. This is very counterintuitive, Dima. So what can you say about this competition thing? When you make a tender, everybody thinks that the price will be better, right? It's 22%.
Yes, I know. So we are not against the fair competition, actually. So the trick is that you can get the best possible price with the entire annual volume, and if if your tactics will be splitting the volume across the different suppliers, then you will never get the best price. Actually, that's the trick. So the tender makes sense from the perspective of long term. When you are choosing the right kind of supplier, you will go with, but not with every purchase, every incremental step of growing your infrastructure. So you have to rethink the purchasing strategy. You should be project thinking rather than, just I have an organic growth and I will just won't buy one more server and etc. Something like this.
Yeah, that's one I'd like to add, because whenever you change platforms or technology providers, you have to do as a minimum a POC, if not a full-blown qualification. So 1 year set and done, the incremental cost comes down to the cost of the hardware and doesn't drive additional engineering.
That is quite interesting, because interesting different perspective on this matter. Okay, so I see that everybody oh, there's a question. How about data migration after the lifetime of the hardware? Will this be hard project or very smooth data migration?
Do we have Alexander during this session? Alexander, can you hear us well?
I think Alexander is a little bit muted at the moment, but this is a great question. Actually, thank you for asking, and we will give you the reply when we send out the handout materials from the webinar. This is a great question. Techonomics expert will contact you and give full introduction to data migration aspects. Okay, I think it's a wrap up. Thank you very much, Manfred, for being our special and very informative guest today on the Western Digital Technology. Thank you. Thank you everyone for joining us today, participating in the quiz and asking questions. This was a wonderful experience. So we are wrapping up the advanced storage for demanding workloads webinar from DIAWAY and Western Digital. Make sure to subscribe and follow us on Twitter, DIAWAY Corp, and LinkedIn, DIAWAY Corp. So join us and follow our news. We will have a lot of amazing news in the upcoming weeks. Thank you for being with us today, and have a wonderful time. Stay safe, stay at home, wash your hands, and don't touch your face.
Thank you.
Thank you. Bye-bye.
Cheers. Bye-bye.